Hello everyone. Now let's use an example questions from your textbook to let you know the margin of error and the interval estimation. And in the example question of the Lowe's department store, we can calculate it out the margin of the error. And if today we know the sample mean of it, that is the S bar is 82. So following the formula that the um, S bar can add or deduct the margin of error, so we can obtain the interval estimation by the 95% confidence level. That would be the 82 positive or negative 3.92. So this is a specific interval estimate of the mu that based on the data we get. So you can calculate it. That is when the 82 deduct the 3.92, you will get 78.08. And when you use 82 that a 3.92, you will get a result that is 85.92. And they express an interval for your estimation. And then because the 95% of all the intervals construct they can using such formula, so we can say that there are 95% confidence that the interval 78.08 to 85.92 that will include in the population mean mu. And in such example questions, you will also know the 95 percentage is a confidence level, and the 0.95 we can refer it as the confidence coefficient, and the interval that is from 78.08 to 85.92 we can call it the 95% of the confidence interval. So here you will find the interval estimation of the mu. We can express it by such formula that is the mean of the result, that is the S bar, and we can add or minus a Z value, but it will be expressed by the alpha, that is the confidence level be deducted and divided by 2. Okay, you need to use that to find the Z value and multiply by a simple the standard error from the sample, and the Z value that with the probability that is alpha divided by 2. That means the Z value that will providing an area of the alpha divided by 2 in the upper tail of the standard normal distribution. So in such formula, you will find why we need to divide the alpha by 2. That means there is a 1 minus alpha probability that the value of the sample mean we will calculate. So if it is a normal distribution, then we will know the probability we would like to know. But out of the probability, because it is a normal distribution, so it will follow a normal distribution curve, that is the area will be symmetry. So we need to calculate such area by the Z value that using the alpha divided by 2, so that can make all the probability will be 100%. But if we know such part, then these two other side we need to use them and divide it by 2. Then we will check the Z value of it and multiply by the sample standard deviation to get the interval that is the mu 8, the Z value of the alpha divided by 2, and multiply by the standard deviation of the sample, or the mu minus the z-value of the alpha divided by 2 and multiple by the standard error of the sample. So here, if you calculate it, you will find today the confidence level, because in our example question is 95%. So the alpha is 0.05 and the alpha divided by 2 will be 0.025. So you will check your normal distribution of the probability table to get the z-value of the alpha divided by 2 is 1.96. And if today the confidence level is 90%, the alpha will be 1.1. And then the alpha divided by 2 will be 0.05. And if you check the table, you will also get the z-value of the alpha divided by 2 will be 1.645. And then you can calculate out its area. Then if you find the confidence level today is 99%, then the alpha will be 0.01 and the alpha divided by 2 will be 0.005. So in such conditions, you will also get the z-value of the alpha divided by 2 will be 2.576, and the table of the area will be 0.995. And if today you don't want to memorize such z-value, you can check by the table. But if you would like to save your time to check the table, I would like suggest you to memorize the z-value for such confidence interval. So today, if in the example questions we find the 95% of the confidence level, we can find the coefficient, confidence coefficient will be 1 minus the alpha. You will get the 0.95 and the alpha will be 0.05. So if we would like to check the z-value of it, we need to divide it by 2 to get the alpha. Half alpha result is 0.025, and then we can check the z-value of the 0.025 is 1.96. So you can follow our formula that you get the S bar is 82 and the standard deviation of the sample is 20 and the sample size is 100. So follow your formula, you will find the interval will be 82, 8 or minus 1.96, and then multiple by the standard error of the sample, that is the standard error of the population divided by the root of the sample size, and get the same result from what we had been calculated before. So the margin of the error will be 3.92, and the 95% confidence interval, it will be 78.08 to 85.92. So following such questions, you can also calculate when the confidence level is 90%. So if the confidence level is 90%, then the confidence coefficient will be 0.90 and the alpha will be 0.1. So in such conditions, we can calculate the z-value of the alpha divided by 2 to get its z-value will be 1.645. So the confidence interval by the 90% confidence level following the formula is the S bar. You can add or minus the z-value of the half alpha and multiple by the standard error of the sample. So you will get 82 to add or minus 1.645 and multiply by the standard error of the sample and divided it by the sample's root of the sample size to get the result is 3.29. So the confidence level when it is 90%, you will get a confidence interval that is from 78.71 to 85.29. So because the 90% of all the intervals constructed, we can using such formula that is S bar to 8 or minus 1.645 and multiply by the standard error of the sample. It will contain the population mean. So the 90% confidence, we can say the interval will be S bar 8 or minus 1.645 and multiply by the standard deviation of the sample, which includes the population mean mu. So the 90% will be the confidence level, and the 0.90 it will be the confidence coefficient. So also by the same calculation method, you can try to calculate when the confidence level is 99%. So you can practice it, and that's today's we introduce in such topic about the interval estimation when the standard deviation of the population is known. Thank you.